Hello. Okay, so today we're going to be going over the unit circle, and in your book you can find the unit circle section. It is 443, and it's pages 242 to 253. So, I'm not going to ask you this because you're online, you can't answer. So, what is the unit circle? I'm going to Google it because what does it mean? Okay, so the unit circle is a circle with a radius of 1 on the coordinate plane that is centered at the origin. It provides a visual way for us to think about trigonometry and trigonomic functions. So what that basically means is this point in the middle is 0, 0, and then the distance from the middle, from this point to the edges, is always 1, all the way around the circle. And what we use the unit circle for is to find the value of trigonomic expressions without the use of a calculator. So we just look at the unit circle and it'll give us the values that we need. So, the three trig identities that we use when working with right triangles were sine, which is equal to opposite over hypotenuse. Cosine, which is equal to adjacent over hypotenuse, and tangent, which is equal to opposite over adjacent, or sine over cosine. Hypotenuse over adjacent over hypotenuse. And your hypotenuse will cancel out, and then just give you opposite over adjacent. So in short, tangent is equal to sine over cosine. That's what you need to remember for the unit circle. So on the unit circle, your sine value, so your sine value is always equal. These values all the way around the unit circle, sorry, I kept forgetting what I wanted to say, are all in the form of x comma y because they are pairs on the coordinate plane. So your cosine is always your x value and your sine is always your y value. So I'm going to go through these and practice with you. When I downloaded this presentation onto Smart Notebook, it didn't download right. So anywhere that you see a question mark, it's actually a pi symbol. Okay? So first we have sine 135. So what we do is we find 135 on the unit circle. 135 is right here. So then we find our y value, which is the second value. So this is just equal to sine, or square root of 2 over 2. And that's all we have to do. So then our second one is cosine 5 pi over 3. And so we gotta find 5 pi over 3 on the unit circle now. So 5 pi over 3 is right here, and we're finding cosine. So we're going to look at our x value, which is equal to 1/2. Okay, so now we're going to work on finding our tan 60, but remember how I said on the last slide that tan is equal to sine over cosine? Well, when working with the unit circle, this means that tan is equal to y divided by x. So let's find, we're at tan 60. So we're going to find 60, and then we're going to find our y. So equal to square root of 3 divided by 2 divided by 1/2. So then, how we divide this, we multiply it by its reciprocal. So our 2's cancel out, and we're left with square root. And that is our answer for what tan 60 is equal to. So now we're going to do, sorry, I'm running out of room. I'm trying to figure out what to put. So let's do cosine pi is equal to, pi is right here. We look at our x value. So cosine pi is equal to -1. So now we're at tan. So now we're going to do tan 210 is going to be equal to 210 is right here. So then that's going to be equal to negative root 3 divided by 8. Do the same process we did on the last hand problem, and we would get negative 3. Oh, wait, nope. I switched the x and y value. My bad. I knew it didn't look right. So we got negative 1/2 divided by square root 3 divided by 2. And then it was half times 2 over square root 3. That's going to equal, these are going to cancel out. These are both negative, so our negative signs cancel out, and we're left with tan 210 is equal to 1 over square root 3. We're running out of room. Okay, so I'm going to do, sine is the last one. Sine 3 pi over 2 is going to equal, 3 pi over 2. We look at our y value, it's going to equal negative. That's how you do it. So now we're going to talk about finding reference angles. And a reference angle is an acute angle between the terminal side of an angle and the x-axis. So in quadrant 1, it's this angle. Quadrant 2, it would be this angle. Quadrant 3, this angle. Quadrant 4, this angle. So in quadrant 1, we find it just by looking at what they give us. So if they give us 30, 30's in this quadrant, so then it would just, our reference angle would be 30. If we're in this quadrant down here, let's say, or this quadrant down here, my bad, let's say they give us 150. So we take 180 minus 150, and we would get 30 as a reference angle. On this one, we're above 180, so we're down here, which means we would take an angle bigger than 180. So let's do 220 minus 180, and that would give us 40 as our answer. So then our last one, got 2 pi 60, 2 pi and 360, my bad. So let's say they give us like 330. As the angle that we're trying to find the reference angle for, we just subtract them, 30. So then on this side, so let's say we're given, it didn't include some of it. I have angles already pre up here. So let's say we're given 140 and we're asked to find the reference angle. So where's 140? 140, 135 is here, 150 is here. So 140 has got to be somewhere in this one. So we would just take 180 minus 40, and that would give us 140. Oh crap. Our 180 minus our 140, and that would give us 40. So let's do pi. So then for pi we would use pi is right here. So we could subtract pi from pi and get 0. And that makes sense, right? Because the reference angle is the distance between the x-axis and the last side of the angle. Well, 180, this is our angle. Our angle ends on the x-axis, so that makes sense. So then let's find a couple more. Let's do 280. Oh, and 280 is in this quadrant over here. So we would take 360 minus 280, and we would get 80 as our reference angle. So then let's look at pi over 3. Pi over 3 is in this first quadrant. And remember, in this first quadrant, it's just equal to its sine. So a question that I asked in class was if we would be able to find the sine, cosine, tan values for angle measures larger than 360 or 2 pi radians. The answer to that question is yes. And we can do that by just simply, if we had 3 pi, we'd subtract 2 pi from it. And then we would use this value right here to find the sine, cosine, and tangent values for 3 pi. And same thing with a number that's bigger than 360. So let's say we have 540. That minus that, we would get 180, and then we would use that value. So I'm going to practice a little bit. So we got cosine 390. I'm going to write it bigger. Cosine 390. Okay. So first we would do 390 minus 360. And that's equal to 30. Okay. So then we would take our cosine 30. And then that would equal, where is 30? 30, our cosine is always our x, equals square root of 30 over 2. So then we got sine 7 pi over 2. Take 7 pi, 2, and we would subtract 2 pi from it. But we can't subtract 2 pi from negative 7 pi over 2 because they don't have the same denominator. So what that means is that we gotta multiply both by top 2, 2, and that would equal 7 pi over 2 minus 4 pi over 2. We left with 30 pi over 2. And we would plug 3 pi over 2 back in. So sine 7 pi over 2. Wait, and that's right for me. 3 pi over 2. find 3 pi in your unit circle. 3 pi is right here, and then sine is our y value, so equals -1. Okay, I'm gonna clear this slide now and do the other two. So we got sine 510, then we take 510 minus 360. And we get 150 sine 150 equals. We find 150, we find our sine value, which is our y value, 1/2. We got cosine 10 pi over 3. And we would take 10 pi over 3 and 2 pi from it. We gotta make this 3. 10 pi over 3 minus 6 pi over 3. That would equal 4 pi over 3. So then we plug this in. Cosine 4 pi over 3. Find our 4 pi over 3 right here. Find a cosine value that I wrote over, and it's equal to -1. And that's how you find sine and cosine and tangent values using the unit circle.